What's up, baby birds? Welcome to Lesson 1.2, Introduction to Transformations. This is something that you learned in middle school, and we're reviewing it back again. So, what is a transformation? Do you remember? Take a guess. Think about it for a second. See if you can predict the word I'm going to put right here. Transformations are a what of a point, line, or shape? Figure it out yet? Pause the video, think. Alright, I'll tell you. It is a movement. That is when we move a point, line, or shape. Any type of movement is a transformation in geometry. Okay? And there are four ways we can transform a point, line, or shape. Let's start with the first kind, right? This is called a transformation. And what a transformation is just when you slide something along, okay? Another word for a transformation is called a slide, all right? We're going to call that also a slide, all right? So if you just take a shape and you slide it to a new place, that's our transformation, all right? We take a triangle, stays exactly the same. We don't turn it, flip it. We just move it right over here, right? We just slid it over. That is a transformation. The second one, all right, is called a reflection, all right? We call this a reflection. And if you see here, these are two mirror images of each other, but another way to call this is a flip, all right? We also call this the flip. When you flip something, it is a reflection. So we flipped over this triangle, we flipped it over this line, so we know we are reflecting it. Third kind, all right, if you see what's happening here, the difference between this square and this square, well, that's a rotation. All right, that is the third kind of transformation, and that's another way to put that is called a turn. All right, we just turned it. If I took this square and I rotate it, that is another kind of transformation. And finally, we have a dilation. All right, that is our final kind, dilation. All right, and that's what your eyes do when it sees light. They get bigger and smaller. That is just growing, all right, or lessening. If something gets bigger or smaller, that is a dilation. You look at this circle, got bigger. That's a dilation. This is the only one of these where the size of the figure actually changes. Don't forget that. For these three, the size of the shapes never change, right? If you look, when I slid it, when I flipped it, when I rotated it, the size changed the same. There's just orientation changed. The dilation, the size changes. Don't forget that. All right, now there's some good vocabulary you should learn. All right, there's the pre-image and the image. The pre-image is the object before the transformation. All right, before the transformation is our pre-image. So if we look over here, we have A, B, C, D. All right, this is our pre-image. Nothing has happened yet, but it's been translated over. All right, and after the transformation, we call that the image. So before is the pre-image, after translation is called the image. So this is our image. And you might remember this from middle school, but there's a notation that we use to mark it. All right? So after transformation, we call these, we would put this little comma there, right? So this would be A prime, B prime, C prime, and D prime. That's how we know this is the image. It has those little marks over there, so don't forget to put those. Alright, so we just talked about the four types of transformations. We want to figure out which of these is a rigid transformation. Not all of them are. Some are, but not all. First, we should know what a rigid transformation is. A rigid transformation is one that preserves the distance between points. Now, what that really means, this is a fancy way of saying that a rigid transformation, all right, is one that stays the same size. All right? So if the transformation, after the transformation, it's the same size as the one before, then it is a rigid transformation. If it gets bigger or smaller, then it is not a rigid transformation. But the fancy way to say that is it preserves the distance between points. That's what we're going to use, okay? Preserves the distance between points. All right? So let's look at this example. Is this an example of a rigid transformation? Well, first let's think, what kind of transformation is this? Well, since it's a flip, ABC has been flipped over. We know that this is a reflection. And when you reflect something, does it get bigger or smaller? No, it stays the same size. And since it stays the same size, it is a rigid transformation. So yes, a reflection is a rigid transformation because it preserves the distance between points. Okay? If it doesn't get bigger or smaller, then it is a rigid transformation. So let's go over these. We're going to state the type of transformation each, label the image, and say if it's a rigid transformation or not. So let's look at this first one. In this first one, the shape is turned, right? JHK is turned, so that is a rotation. All right. Let's label this correctly. So J goes over here, that would be J prime. K comes over here, this would be K prime. And H goes over here, this is H prime. All right. Now, when I rotate something or when I turn it, does it change the size of it? Does it get bigger or smaller? Well, no, so that is a transformation, a rigid transformation. So yes, it stays the same size. Yes. Number two, let's look at this. This is a flip. So triangle FED is flipped over. That is a reflection. Okay. Since a reflection, as we talked about, keeps the same size, it stays the same size, this is a rigid transformation, right? It stays the same size, so yes it is. And let's label this E reflects over here, D reflects over here, and F reflects over here. All right? Over here. Well, look at this guy. It doesn't rotate, it doesn't reflect, it doesn't get bigger or smaller. This is just a slide, right? It just moves over here. So this is a translation. All right, translation just slides over. And so A slides over here, B slides over here, C slides over here. And when you slide something, does it stay the same size? Yes. So this is a rigid transformation. And finally, we have this guy. MNO gets bigger. So we have MNO. And when something gets bigger, that's a dilation. Okay? Now, is this a rigid transformation? Does this stay the same size? Well, no, it does not. So this is the only one that is not a rigid transformation because it does not stay the same size. It is not the same size, right? It gets bigger, so it's not rigid. Okay, final part. What transformation maps rectangle ABCD onto rectangle A prime, B prime, C prime, D prime? All right, what transformations happens here? Well, as you can see, ABCD is turned, so this would be a rotation. All right, if it's turned, it's a rotation. Now, there's some language over here. It says maps rectangle ABCD onto the other rectangle. So what does mapping onto means? And mapping onto just means a transform, a point, line, or shape so it fits exactly over the other one. So to map this onto this, well, what I would have to do is basically rotate it around, right? If I rotated it, it would fit directly on top of this, all right? If I rotated it. So since I would need to rotate it, that's how I'd map it onto there. So mapping onto just means what do I have to do to make that fit perfectly over the other one. All right. Going down. All right. What two transformations maps ABC onto A prime, B prime, C prime, and then onto A double prime, B double prime, C double prime? So there's two transformations here, right? Well, the first one is ABC to this guy. And since this is a flip, we know the first transformation is a reflection. Okay? And once it's reflected, well, it just slides over here. So the second one will be a translation. All right? So sometimes you could do more than one transformation. And when we do a second one, we use 2 primes. Now, if we did a third one, we'd use 3 primes. So that's today's lesson. Remember, guys, love your mother with all your heart and eat your cereal and don't pick your nose. That's gross.